Example 1 using the product rule. In part A it says if f of x is equal to x times e to the x, find f prime of x. Well, we can say that f prime of x is the same thing as the prime notation as fg prime. So we know that f of prime of x is the same thing as saying fg prime, since that's what we're looking for. Okay, so the first step here is that we know that we can define f to be x, and we can define g to be e to the x. Okay, and then we're going to use our prime notation because fg prime is equal to f times the derivative, or g prime, plus the function g times f prime. Okay, so the way we'd set this up is we know the function f represents x, and then we're going to multiply it by the derivative with respect to x of g, which is e to the x. Plus, we know the function g is e to the x, and then we're going to multiply it by the derivative with respect to x of x. So now let's go ahead and simplify here. Well, we know that this is x times, well, what's the derivative with respect to x of e to the x? Well, we determined that that's going to give us e to the x. Plus, we have e to the x, and the derivative with respect to x of x is 1. So therefore, we end up getting x e to the x plus e to the x. Or if we wanted to factor out e to the x, then it'd be x e to the x plus 1. We could also write this as x plus 1 times e to the x. So we found a derivative of this function, and now we want to find the nth derivative in part B, meaning what is nth derivative of x. So we need to explore this a little bit. So by exploring it, what we're going to do is we're going to take a look at the second derivative. So what we want to find is the second derivative. So we're looking for f double prime of x. Okay, and we're using the function now, x plus 1 e to the x. Okay, so now we're finding the derivative of this function. So now what we're going to do is we're going to let f equal x plus 1, and we're going to let g equal e to the x. Okay, so what do we know? We know that the formula fg prime is equal to f times g prime plus g times f prime. Okay, so let's go ahead and write this out. So we know the function f here now is going to be x plus 1 times the derivative with respect to x of g, which is e to the x, plus now we're going to take the function g, which is e to the x, and then we're going to multiply it by the derivative with respect to x of the function f, which is x plus 1. Okay, next what we're going to do is now we have x plus 1 times e to the x plus e to the x, and what is the derivative with respect to x of x plus 1? Well, that gives us 1. So now we end up getting x plus 1 e to the x plus e to the x. Okay, now if we factor out the e to the x, then what's left is x plus 1 plus 1, which then equals e to the x times x plus 2. Okay, so let's take a look here. Let's rewrite it like we did here. So that means that we have x plus 2 times e to the x. Okay, now in order to find the nth derivative, let's check and see what happens with the third and the fourth derivative. So, next thing here, let's find the third derivative. Okay, so if we want to find the third derivative, then we're using the function here that we just found, and that function is x plus 2 times e to the x. Okay, and so therefore this is what we're looking for, is the third derivative. Okay, so we're going to call f now to be x plus 2, and g is going to equal e to the x. And again, we're going to use the prime notation formula. So we have f g prime is equal to f times g prime plus g f times g prime plus g times f prime. Okay, so that means now in step number 4, we know that f now represents x plus 2, and we're going to multiply it by the derivative with respect to x of the function e to the x. Plus, we know that g represents e to the x, and we're going to multiply it by the derivative with respect to x of f, which is x plus 2. Okay, now let's go ahead and simplify. So over here we end up with x plus 2 times the derivative with respect to x of e to the x is e to the x. Plus over here we have the derivative with respect to e to the x times the derivative with respect to x of x plus 2, which is 1. So now we end up with x plus 2 times e to the x plus e to the x. Okay, now if we do the same thing we did in the previous step, okay, we can now factor out e to the x. And if we factor out e to the x, then what's left here in the first term is x plus 2. And then this e to the x becomes plus 1. So therefore, we have e to the x times x plus 3. So therefore, rewriting it like we did in the previous step, now we have x plus 3 times e to the x. Okay, now let's find the fourth derivative. So the fourth derivative of x, we're going to use the new derivative, which is x plus 3 times e to the x. And again, in step number 2, we're going to let f equal x plus 3. And then we're going to let g equal e to the x. And then using prime notation, we have f g prime is going to equal f times g prime plus g times f prime. So now we know that f in this problem is x plus 3 times the derivative with respect to x of e to the x, plus we have g, which represents e to the x, times the derivative with respect to x of f, which is x plus 3. So you should be able to see the pattern. So we have x plus 3 times e to the x plus e to the x times 1. So now we end up with x plus 3 times e to the x plus e to the x. And if we factor out an e to the x, then what we end up with is x plus 3 plus 1, which is equal to e to the x times x plus 4. So therefore, we end up with let's go ahead and rewrite that. So it's going to be x plus 4 times e to the x. Okay, so what we want to be able to then determine, again from question B, is what's happening when you find the nth derivative. Okay, so I want you to see the pattern here. Okay, when we found the nth derivative, we can see that we end up getting x plus 1 times e to the x, and then 8 is x plus 2 e to the x. Okay, and then x plus 3 e to the x. X plus 4 e to the x. Okay, now keep in mind here that our first problem, we wanted to find the first derivative. So the first derivative applies to that one. The second one, we found the second derivative, and that was x plus 2. And then here, the third one is f. We found the third derivative, and we had 3. And over here, we found the fourth derivative, which gave us x plus 4. So therefore, we can then determine what's happening with this problem. We can say that each successive differentiation adds another term e to the x. So we can say that f, or the nth derivative of x, is then going to equal x plus n times e to the x. Okay, now let's graph the function and the first derivative on Desmos. Okay, so let's go ahead and do that. So we know that our function is x e to the x. Okay, and then we know that our next function was our derivative x plus 1 times e to the x. Okay. Okay, let's take a look at this graph. So we know that the one in green here is f, which is equal to x times e to the x. And this was the derivative, which is f prime, which was equal to x plus 1 times e to the x. So let's summarize this graph. Okay, so I want you to notice that f prime is positive when f is increasing and negative when f is decreasing. So again, it's positive when it's increasing, and then f and negative when f is decreasing.